Okay, so I think we can get started because I can see all of us are here. Welcome everyone. Today we're gonna see chapter 3, and Isabella is going to lead us to give us discussion on chapter 3, which is more or less about program organizations, which discuss about functions, how you can structure the functions in your program. So without much further ado, Isabella, the floor is yours.
Awesome. Hi, everyone. I am excited to chat today, but I have to admit, there were some sections where I felt a little bit over my head. So I'm really looking forward to discussing with you. Can you see my screen all right?
Yes, we can see your screen.
Awesome. Okay, I'm gonna just stop my because I don't know what I look like. Awesome. So welcome to chapter 3. And so the first part of this chapter focused on scripting. So more specifically, a script is a program that runs a series of statements and stops. A few things to note: that order is important. And similarly, if you're coming from the R world like I am, that generally want to put the definitions of variables and functions near the top of your script. And in a brand new script, if it's not defined at the top, then it won't run further down the line. And so just to reiterate, names must always be defined before they are used. And so in this example where we define the square function, once it's defined, then we can go ahead and assign some values and then actually run the function at the end. So if this square b was above the function and we were rerunning this script, then it would throw us an error. And in terms of functions, there are named sequence of events, or sorry, of statements. You generally want to use a function to put all of the code related to a single task in one place. They help simplify complex operations, and they also simplify repeated operations. So again, if you're coming from the R world, it's a similar sort of idea that if you are finding yourself copying and pasting code throughout your script, you may want to consider writing a function instead. And like mentioned above, functions are defined before they're actually used in the program. And then the book also listed a few best practices, which I really appreciated. One was to use a quote unquote bottom up style, in that the smaller and simpler functions should go at the top of your script and then get more complex as you go down. They should only operate on past inputs and avoid global variables. And so I think the idea there is to be as transparent as possible with the functions that you are writing. If anybody has any specific examples of what it means to avoid global variables, please let me know. There's some function examples in the book that have global variables within a function that I'll point out in a little while. And I am not sure why the recommendation is to avoid global variables. But I think my understanding is that they kind of mask what the function is doing, and that's a bad thing. But again,
Yeah,
go ahead.
yeah. So I think what they say, like I think maybe I read it somewhere, like if we have a function and you are trying to access some kind of global variables, that means you need to go further, maybe to create classes, like so that you can have something more bigger, because functions are used also to make programs monitor to but classes are much bigger than that. So if you find yourself you are accessing global variable from function, then it means you need to create classes. Yes.
Thank you.
So that in the class you can have variable that global to any functions, and any function inside the class can access all the variables in the
Let me know if that sounds right. Thank you. And then some other best practices, and I think just generally the documentation is a good thing. One example is to use a doc string to include documentation. And so you could see that here between these dashes to kind of let you know what this read prices function is doing. And then in addition to that, you can also use what is called a type annotation. And that lets folks know what the function definition is. And so in this case, that it's a dictionary file type. And so yeah, so that is functions and some general best practices.
What this dictionary is it the return of the function or what?
I believe that this is what you're inputting into the function, but if I'm wrong, please let me know.
Okay. So
yeah.
the input parameter is a dictionary, right?
That's how I understand it. Yeah.
Okay. Right.
Yeah, it's interesting because the author mentions this as a best practice, and I don't think he does it ever again in the chapter. So I'm not sure if it's because the type is ambiguous and therefore it can't be like defined in the function any other place or some other reason. I just thought that was kind of funny. I was like, oh no, I can't see another example of how to use this. I guess I could have Googled it, but I didn't.
Yeah. Also, related to the best practice of this docstring that you made mention. So sometimes you see when you open the docstring, the first line explain what the purpose of the functions, and the subsequent lines sometimes they explain the argument, the parameters, what the parameters and their type, and also the return type of the functions. So maybe if we finish on time, I can show it like in VS Code. You can use something that automatically generate based on your argument. It automatically generate the argument and the return type for you, so that you just fill dummy stuff and you fill it. Yeah. So sometimes you can see the docstring explain the input parameters of the function and also the return type.
And return type. Got it. Awesome. That is super helpful. Yeah, I have never used VS Code. I've only ever used Jupyter Notebooks, and it's kind of funny too, because in the book he mentions like, don't use Jupyter Notebooks. And so when running the exercises, I try to use the interpreter as much as I could, but for actually writing the notes, I only know how to use Jupyter Notebooks now. So a little bit more on functions. You can call, like you just mentioned, the arguments within the function itself. So in this case, there's two different ways. So one is positional. So in the argument or in the documentation of the function, the arguments are, and the creation of the function, the arguments are listed in a certain order. And so if you write the corresponding argument options that you want in that order, Python will be able to read it this way. So in this case, there's some argument here, and you're letting them know, I really want it to be true. And then another option is to actually use the keyword for it. And so in this case, regardless of the position in the function itself, you can just say, I want debug equals true. And so the author does mention that having being explicit in when you're writing out your function with the actual keyword is better, even if it's default, because that way it's really clear. When you're reading this, you're like, for somebody else who's completely new to your script, they might be wondering what on earth is true, being true for, versus like being able to read debug and being really clear, oh, this is about debugging. And just a few other things about arguments. You can define defaults that need to be overridden. So if the default is debug equals true, and you run this without that, then it's able to just read it and have debug equals true, and it needs to be debug equals false if you want the opposite. Some things to also note as you're writing out arguments, all non-optional arguments go first, and the optional ones go towards the end. Again, having the keywords actually improves code clarity. So even if they're not necessary, he recommends writing them out. Excuse me. In your, sorry. Sorry, that's what so having the keyword improves code clarity, and then and then always have functional, nice, meaningful names so that folks know exactly what they're trying to argue. Any questions about arguments or additional thoughts? Okay. Not returning values. And so the return statement returns a value. So in this function that we created up above for square, it says return x times x. And so if you run this, it will return the result, in this case, 4. And if it doesn't say return within the function and you run, none is returned. So as you can see, nothing actually showed up because we don't have a return. This one, I welcome your thoughts because this is directly from the book. And so functions can only return one value or return them in a tuple. And the example in the book has this divide function that divides A and B and returns Q and R with the quotient and the remainder in a tuple. But when I run this, it actually doesn't return anything, even though there's return in the function. Does anybody know why that may be?
I guess because you didn't have it as like when you're running the function, it should be something equals to that function. Then it exports that the output Q and R into those variables. Essentially, you need to add another line, for example, call it QQ, comma RR equals to divide A and B, and then see the results there. Or essentially write down that QQ and like print QQ and RR, something like that.
I see. So like,
no, not here. Outside
okay.
of the outside of the function.
Yeah, I do see, like, if you list the object, it does return it. I guess I'm wondering, like, why doesn't it do it like?
There's no D equals at the start of that line in the book.
Yeah, I was gonna mention that.
Yeah.
Just two
Okay.
equal signs in the beginning.
Wait, sorry, where?
No, you just had it.
Oh, I did. Okay, so delete this.
Yeah, delete
Yep, and
this,
then
and at the last line instead of D, put X and Y.
Oh,
because the line
yes.
above it, it generates the values, but it doesn't create anything to show it. So in the last line that you have now, just clean, yeah, and now type X and Y.
Like that?
And that should do it.
Hey, awesome, thank you. I did not know that, so appreciate your help.
Yeah, so let me just add something. So here it means what they were saying, like the function can only return a single value or return them in tuple. So here sometime you may see that here we have return Q comma R. So Q comma R is just a tuple. Sometimes you may see that people just write a bracket, return open bracket and close bracket. So a tuple, essentially what makes a tuple is just the comma. So yeah, so this is just want to add that you may see people just write it without comma, but it's still a tuple. It's not returning something more than one object, but it's still a single object as a tuple.
Thank you. Thanks, Paul. So moving on to variable scope. And so this is a little bit what we were talking about earlier, global variables, and then the other option is the local variables. So global variables are defined outside, and they, like, functions can freely access all of the values globals in the same file. That's really important. However, one thing to note is that functions can't actually modify global variables. And then if variables are inside a function, they're called local, and they're not retained or accessible after the function call. And so here's, I just like made up this example of using name as a local variable, and running this gives you hello Dave, but we can't use this outside of that in another context outside of this function, versus in this case, having name be outside of the function, you can still refer to it within the function. And then it can also be reused with another function if we need it to be. Any additions to variable scope?
Nope, all good.
Cool.
So yeah, so what about, assume you want to go up a little bit. So what about now inside this function, you want to access a global variable name. Name is equals to dev, right? So inside this function, you want to access okay. Right, yeah, inside this function, maybe you want to modify this name variable.
Inside this function?
Yes, inside this function. How can you access name global variable outside and modify its is?
How can you? Well, down below here, they talk about like whether things could be modified in place. Does anybody know, like, how do we reconcile like the fact that like functions cannot modify globals, but that things can be modified in place? That seems
so
contradict each other a little.
I want to remember something. There is a keyword called global. So for example, inside this function greetings, you can say global name. And now you can actually, using the keyword global, it means you are referring to the functions in the global, and you can modify its constants.
So like this global.
Not in the calling, in the function definition. Maybe you can just check it. There is a keyword global that can be used inside a functions to access global variable, and you can modify the global variable inside the function. Because here you can see this function, you just call the global variable called name and you print it, right? This means that this variable name, you cannot change it. But how can you change this variable called name? Because the scope inside the function, it does not have a scope, but you can use a keyword called global that you can use to modify the global variable. So this is just what
Cool. Is it a way? Oh, I see. Globals will return all of your global variables. Oh, that's awesome. Let's add that. Globals. So, lost the chat.
Yeah, just add the parentheses after the S.
Okay.
It returns a dictionary containing the global variables.
Sweet. Cool. I guess kind of related is how to modify values. In this case, we have a function called foo, and this one actually modifies the input object. So it's going to append 42 to the items that you give it. And so in this case, A is originally 1, 2, and 3, and then running foo on it. When you print A again, now you see it's actually changed. Excuse me. It's now 1, 2, 3, and 42. And compare that with this option where the function bar, once you give it items, it's 4, 5, and 6. You can use bar on, oh, that's right, it's going to print the last thing. I do this. Oh, return none. Oh, that's right, because there's no return. In this case, like B is not actually changed once you pass bar to it or pass it to bar. It returns back to its original state because in this case, it wasn't actually modified. Anything I've missed here or to add? And it returned none because there's no return, which we just covered. Yeah. Ooh.
Yeah, so the function didn't play any role here, right?
Yes. How? I'm sorry, y'all. I'm very, very new to Python. How do I print bar B knowing that there is no return in the function?
You mean the average of the?
Oh no, just like print the 3 numbers.
No,
So
so
B?
you can,
Oh, sorry.
so without return, I think the function cannot do anything, right? Even if you have bar B's, even if you define B what it is, the function doesn't do anything, so there won't be any return, right? So there is no side effect or anything.
Yes. So I guess like I was assuming passing B to bar would give us 4, 5, and 6.
No, but
No?
we don't we don't ask the function to do anything, right? Because inside the function, we just declare a variable and assign a list to it, right? We didn't say the function to do anything. So even if we call the function bar, we give it the input, it won't do anything.
I see. That must be why it doesn't, nothing happens.
Yeah.
And B stays the same. Cool. And I realized I think I might have skipped over some of the exercises to just go through that really fast. Sorry, I have a cough. So the first exercise has us calling back our report.py module that we created a little while back. And so I think the very first exercise just had us, oh no, I'm sorry. It asked us to modify the program so that this particular part, this operation of naming the headers is, and printing out the report is in a function as opposed to a series of operations within our script. And so to do that, just remembering the things that we had talked about, we want to define the function and whatever we put inside of it. We can add a description here, and then the rest of it looks very much the same. And so now, as opposed to a series of operations, now it's within a function that we can pass it report data to actually run. And then the second exercise asks us to put all of the things that we wanted in the program in a top level function. And so it runs a series of different things as opposed to just like one different thing. So here we have reading the portfolio file, a function for reading the prices file, making the report data, what we just did, which was printing the report data. And then finally, putting all of that all together. So one function where when we pass it the portfolio file and the price file, reads both of those files, creates a report and prints it out. And then here's the example when actually running it with the data set that we were provided. We get the nice printed out report, all from just one function call, as opposed to doing, however many, 4 of these are, instead of doing 4 separate ones. Any questions or thoughts about this particular exercise?
Sounds good.
Cool. And then for the next exercise, we have this file parse.py. And I think this very first part was just defining it. I think we were already provided it in the book. And this is what it gives us once you pass it the portfolio.csv. So it gives us a nice, it turns the CSV into a nice list of dictionaries. And that looks like this. So the next part is building a column selector, which I could in the book was actually provided for us. So that was really nice. But trying to make sense of what it actually does, it took me a little while. It's like thinking about it, but the way that I understand it is that if you're given a list or a header, for example, then you try to find the index of that header, and then select the columns that match those indices, and then and so the actual columns are mapped to the row indices instead of just pulling the columns directly. And so that's what this ended up looking at like. And then within our function itself, we add select equals none as one of the arguments. And so the default here is none, as in I want all of the headers. But if you do put in a header headers that you want, then it enters this if else statement and then specifies the specific headers that you want when you parse the file. So should be able to run that. And so in this case, you can see we let the function know we just want name and shares, and that's all that shows up when we actually run our function. And then the next series of exercises are kind of similar, like just like trying to make it so our function is more defined, more specific, and gives the user a lot of like different options when reading the file rather than reading all of it all at once, or in this case, just getting more information. And so that here it's modifying this parse CSV function so that, oh, oops, I think I might have missed one. I'm so sorry. This one should be that you can actually read the CSV even if it's even if it doesn't have oh no, I'm so sorry, I'm so confused. Performing type conversion. So it can work on such files without headers by creating a list of tuples instead of, yeah. And that should be down here. I think I just totally mixed up the exercises, so I'm just going to skip ahead. In this case, this is if you do parse CSV on something that doesn't have headers, what you want it to do. And in this case, it checks to see if there are headers, and if it has headers, is the default that it does. And if it's false, it doesn't have headers, then it will create a list of tuples instead, so that you can continue reading it even without headers, and it doesn't do anything wonky. And so, and then if it has headers, use this next rows to, and I looked up the next function, it returns the next item in an iterator set. And then running that, running a particular file that doesn't have headers, so has headers equals false, you can see it still works even though it doesn't have headers. And then the last one was just picking a different delimiter. In this case, it was pretty straightforward. All we had to do was add it as an argument to our function because this CSV reader already had it within it. And so depending on what you want it to be, whether you want it to be a comma or a tab, you would just change it in the arguments here. Okay, and I think that's it for this chapter for exercises. Any thoughts, questions, things that you ran up against as you were trying them out?
Sounds good to me.
Yeah, cool. I think I just put this wrong. That's why I got confused. I was like, wait, what are we doing here? But in this case, this is checking to see the type of, and so func gives the type of a particular value, and then it ties it or zips it into the row. Let's see if I do have it here. There we go. And so this is letting you know, like, I want a string, an integer, and a float, and that is passed to the data set here. Yeah. Excel. So now we're going to move into error checking. So as a warning, Python performs no checking or validation of function argument types or values. And so to be a good programmer and be aware of what exactly is going on in your code, one should use exceptions and use raise to raise them. And they generally have an associated value like this that lets you know exactly what is going on. And the more informative you make them, the more useful they'll be. And so an example is we have this authorized list. And so if it's not an authorized, if you pass it a name that's not an authorized, erase and runtime error, or an error that lets you know that this name is not authorized. And so if you recall, we have Dave defined as the name global variable. And so running it against this, you get here the error, Dave is not authorized, which is a lot more informative than something than some of the errors that Python gives you. So the author's recommendation, it says, don't catch exceptions, fail fast and loud. If it's important, someone else will take care of the problem. Only catch an exception if you are that someone. And that is only catch errors when you can recover and sanely keep going. And so from what I understand of this statement is don't be purposely trying to see what fails. Like if somebody, over time, like folks have only ever put in alpha, bravo, and delta, and this never happened, then there wouldn't be an exception. But if somebody tried Dave, they see an error and then raise this exception. That's how I understand it. Is that how everybody else interpreted the statement as well?
Me too. We are in the same boat. I don't know.
Yeah, I'm like, okay. I guess like there's like an endless supply of things that could go wrong, and so it doesn't make sense to try and cover all of them. But I'm like, okay, that makes sense. So in terms of actually trying to catch them, once you are that someone and you're trying to catch them. The author says to use try except to do that. And there's a list of built-in exceptions that he links in the book. And one thing to note is exceptions propagate to the first matching one. And so the way that I understood this is, so here is where the exception is raised. This is the one that actually will, oh no, I'm sorry. This is the one that will raise the exception once it's run. And here is where it's actually run and caught. And because like it kind of stops here, it won't go on to the next function until this is fixed. So I kind of wish like I had like an example that I could actually run to see how like it looks like when it gets stopped in the middle. Because foo in this case will never actually be run. It will only be run up to bar and fail. If anybody has any examples, like please let me know. I'd love to like replace this in the notes with something that people can actually run and actually visually see what it looks like to have an error stop. And then in terms of catching multiple errors, you can you don't have to do try and accept a bunch of times. You could just have one try and then all the various accepts underneath. And there's a bit of a part in the book about catching all errors, but ultimately, like this is the one that he says to do. Like if you actually, if you want to see all of the errors at once, there's a he lists out a bunch of things that you shouldn't do. But I was like, oh, I don't want to do what you shouldn't do. So here's his recommendation for the thing to do to catch all of the errors. And you can see we got one here because go do something's not defined. And the computer said no. And then there are a few things that kind of go around the exceptions. And so one is finally and with statements. From what I understand, finally, which is linked here with try, is an older way of doing it, but one way that makes it so that this line of code will always be executed no matter what. And then a more modern looking way that's equivalent is using with. So it seems like it's kind of up to your preference. I don't know if anybody has like pros, cons for either one, please let me know. Cool. All right, I think there are a few other exercises associated with the errors section of the book. And so here we want to go back to our file parse .py file, and we want to modify it so that an exception gets raised if both the select and the has headers equals false arguments are passed. Because as you recall, select selects the specific headers that we want, and has headers equals false means there are no headers. And so what is it supposed to do at that point? And so this is what it looks like. So it's an if statement if both select and select has something and has headers is false, then raise this error, and it just lets you know select requires column headers. And I noticed that in the function, he put it at the very beginning. I don't know if like that's a best practice to have your exceptions listed at the very beginning of a function. Again, if you know, please let me know. But I did know, I was like, oh, where does he actually end up putting that? So. And then the next exercise is some more catching. And so in this case, we want to catch all the value error exceptions generated during record creation and print a warning for the rows that can't be converted. And so if you recall, this is the argument that says like, oh, we want these specific columns to be a certain type, or rows, I'm sorry, rows to be a certain type. And so in this case, to try and do that, that conversion, and then so try it and accept, and then the various different error messages that you would get if it couldn't be converted, and then to continue on. Then there's an error because I don't think I actually ran it. And then I think the final exercise for this section is to make it so that the errors can be silenced if you would like. And so in this case, when there's this exception with value error, and then in your arguments, you can put silence errors equals false or equals true. And if it should be, if not, sorry, no, I don't. Oh, sorry, does anybody know if not, does that mean if not the default? And I guess like kind of what I'm thinking is in this case, and not, I might be mixing them up, apologies, but the
I
way
think it's just the opposite of the variable that gets passed in.
I see. Okay, thank you. So in this case, if silence errors equals true, oh, sorry, getting mixed up. Silence errors equals false, then don't print these. And if silence errors equals true, then print these. Any thoughts or questions on these series of exercises? Just adding error messages and all that.
Well, what was silence errors defined as or assigned as? Yeah.
Yeah, so it is by default false.
It's a parameter that's false. Okay.
Yes, and then the only other change is to add this line in the exception.
Got it. Okay.
Cool. So yeah, I feel like this chapter is like a lot of like, again, just building on the same function to try and make it more and more useful, which is pretty neat. Cool. So the next section is on modules. And so again, from my understanding, a file equals a module. So any Python source file is a module. And you can import modules with import. So if anybody has done like data manipulation, done like import pandas, in that case, importing the pandas module. And I actually did not know this, but coming from R, I've heard of the word namespace, but I didn't know the module is sometimes said to be a namespace, and that's because the name is directly tied to the file name. So I learned that. You can use a module as a prefix, in this case, food.org too. And this is particularly important because if you have this this grok in two different files in foo and say bar, you can specify which one you mean by adding the prefix of the module name to grok, so that way it's like very clear which one you're referring to. And the names of all the global variables and the functions are defined within that file, the source file. And like I just mentioned, you can refer to a variable of the same name in two different modules. That is, modules are isolated from each other. And the way the author put it is each module is its own little universe. And so the global variables, in addition, are global only to that particular module, not all modules that you're using. And so when a module is imported, all of the statements are execute one after the other until the end of the file is reached. And that's what happens when you use import as, oh, I'm sorry, that's when you use import. And one thing to note is you can abbreviate the name or change the name of the module as you import it. So I think this is pretty common. Import pandas as PD, or import numpy as NP. So that way you can refer to pandas as PD throughout your code, as opposed to having to write out pandas. One thing to note is each module loads and executes only once. And so if you like run import again, it's just going to refer to the previously loaded module. It's not going to reload it. And so if you have changed something in your module or something else, you want to reload it for whatever reason, you want to quit and restart the interpreter completely. And then another thing to note is Python looks for a specific path when it's looking for modules, and you can adjust this path if you need to. And then one more thing to note is that you can pick certain things from a module rather than all of them. As I mentioned above, all of the statements execute after another, but if you want specific statements, you could use from. So an example is from math, import, just sine and cosine. And if anybody, again, is coming from R, I do this like with, say, I don't know, dplyr : mutate. So that way I'm only using a mutate if for some reason I'm only using that once in my code. And so regardless, like if I think this should be up there, like if you use import pandas as PD, it's not going to change the actual way that the module works. It's going to work exactly the same. Any questions on modules or things I should add or experiences folks have had? Cool. Okay, this part, it was definitely, I was like, oh man, I don't know if I fully understand what's going on here. So welcome any commentary on the main module. And so the book defines it as a source file that runs first. And there's various different ways of running these modules. You could import it as a library import, which like is at least what I'm more familiar with just import, or you could run it as a main here in the terminal. And usually, okay, the statement says, usually you don't want statements that are part of the main program to execute on a library import. And I do not know why. So again, I welcome any thoughts on why this may be. Yeah.
Yeah, I don't get it as well.
I was just like, okay, I believe you, book, but
There in Stack Overflow, I'm no, sorry, Stack Exchange, there is a few posts. I will try to find it, but extensively they describe what it means to have that phrase. And like not having it doesn't create any issue, but having it, it seems it's like it adds something. I didn't get it back then. I'm gonna review it again, and maybe if you guys read it, you can help too.
What the question is?
in the book, the author mentions you don't want statements that are part of the main program to execute on a library import. And so to avoid that, you use this. Yeah, welcome any resources on what this could mean. Yeah.
Yeah, I mean, I think Begley, I forgot, but I think the main idea is, so if you import the file, I think if name is equal to, because this danda, what is it called, danda, this double underscore is called danda method, right? So danda name, if the name of the file is the same as the main, then don't execute it. But if you are running the file like as a script, then you can use something like that. I don't have the, yeah. Okay, maybe you can open it and we can see it.
Oh, sure.
Yeah, I'm not sure this is a Python 2 version thing, but I'm gonna read up on it as well.
Yes.
I found a post on Stack Exchange. I'm sorry, Stack Overflow. I
Yeah.
put it in the comments.
Thank you.
So, mhm,
Can you see it? Okay.
yeah.
Okay.
Yes.
What is name? So, okay, like you just went under alias. I didn't know. It's a global variable similar to global.
Yeah, so can you scroll a bit?
Yeah.
Okay. So you see like here where we have script and we have test file.py.
Mhm.
And if you have this print and dunda name, it will give you the result is name dunda main. That is, so it is comparing if name dunda method name is equals to name, then it is a script Python scripts. This means that you should run it as your main function. But if it is module, so we see that if it is script and you print dunda name, it give you name, right? Let's see if it is module. What will happen now? Underscore. Yeah. So if it is module or package, then if you have dunda method, something like that, it will not give you the main. So notice that when you use in a packet or module name, text the name of the file, the path of the actual module or packet path is not given, but has its own dunda align.
There is another answer in that website, in that thread that has like 8,000 upvotes. There is a short answer and long answer. The short answer essentially says that if you have that, that helps you to protect, to run whatever you imported at the time of running. So it gives an example and says, if you don't do it, there is a chance that whatever you imported, yeah, right there. The first bullet, essentially, then the second script will trigger the first to run at import time. And then it goes through the second script.
I
Yep.
see. So it's so it has to do with like the order of scripts, and
it's kind of making sure, yeah, the order is in place and it's not running the wrong name.
Okay.
And it's just importing what it's supposed to import and then compile.
Okay. And am I correct? Like this is something that you would put in a module at the top, say? Like in a .py file?
I never, I didn't do it, so.
No. Oh, I'm asking anyway.
Nice. Maybe you want to comment on this.
Yeah. Okay. Cool. Well, thank you. I think this is great reading. Thank you so much. Awesome. So just to wrap up this chapter, in terms of the command line, as we may have been doing already for this book, you can often use it for command line tools, and you can run like a list of things all at once like this, rather than just one by one. This is something that's completely new to me, but there's something called standard input output that are files that work like numeral files. I need to think about like an R equivalent for me to understand it, but something to just note. And this one I've heard of from R, if you're coming from R, the environmental variables that can be set in the shell, or you can edit this directory os.environ to edit the dictionary that contains these values. So in this case, our name is Dave. And that you can exit the program. And the final section of the book is, or of this chapter, I'm sorry, is more on kind of like designing. And so one option is to provide a file name, and then another option is to provide lines. And the question that the author asks is, which one do you actually prefer? And so in this case, the second version, it can expect anything. It doesn't have to be a file. And so there's a lot more flexibility. And so then the author asks, like, which one like is quote unquote better? My feeling from the book was that the author was leaning towards having this flexibility because, because depending on what people, the file that they have and the type that they have, that they might prefer to read it in this way as opposed to being restricted to have a file name. I thought that was interesting because, I've had experiences where folks try to put it in files that are like not custom, and it just creates a lot of headache like further down the line trying to like make things work. But it just seems to be a more philosophical question in terms of like what kind of work are you doing, what is the purpose of what you're working on, and which like level of flexibility is ultimately better for your users. So welcome your thoughts, but that is all I had in terms of the book.
Oh, thank you, Isabella.
Yeah, thank you all so much. I learned so much. It was definitely like reading the chapter by myself. I was like, what? So, really
You used to
appreciate your
yeah, you used to R, right?
yeah. I was like, I've never had to worry about this before. So I really appreciate getting to be in this book club with all of you. So.
Yeah. All right. So next week, we're gonna have which chapter? The tell you the one, right? Classes.
Yes.
Right. Okay. So next week is gonna be a big chapter. I classes. One of the building block of doing object-oriented stuff. Yeah. So I'm really excited to see what we're gonna see next week. So I think without much further ado, if anyone want to say anything regarding today's session, yeah, we can discuss. If not, I think yeah, see you all next week.
Thank you, Isabella.
It was
Thank
great.
you all.
Thank you, Isabella. Thanks.
Okay, thank you. See you all next week.
See you next week. Bye.
Bye.